Today we're going to be solving systems of equations in 3 variables. So far our systems of equations have been 2 equations with 2 variables, and we've looked at where the 2 lines cross. Let me show you an example of what we're going to do today. In today's we're going to have 3 equations. So for example, my first equation is z equals 2x plus 3y. And when I graph that, I get something that looks like this. Now instead of a line, I get a plane, which is a flat surface, kind of like a piece of paper. Imagine it extending indefinitely in all directions. Then we'll graph a second equation, z equals x minus y. That looks like this. So now you'll notice that when you have 2 planes, here I have 2 planes that intersect in a line. And here's my third equation I'm going to add, z equals x plus 2y. And now you see that I have 3 planes, and I can actually find the point of intersection, for this case anyway, and I can find where those 3 planes intersect. And that's what we're going to do algebraically. Here's our first example, so you'll want to copy this down. Use these 3 equations to solve for x, y, and z. Now in some situations there will be an obvious place of where to start. For example, notice the first equation only has an x, so I'm going to start by solving that equation. So 3x plus 8 equals 2. I'm going to subtract 8, so I get 3x equals negative 6. So x equals negative 2. So actually, I now know my first point. Next, if I look at the second equation, I can figure out what y is if I substitute the value for x. So I'm going to have 7 times negative 2 plus 3y equals 1. So we get negative 14 plus 3y equals 1. If I add 14 to both sides and then divide by 3, I get y equals 5. So now I know x and y, and I just need to find z. Well, in this last equation, I can substitute those values. So 1/2 times x was negative 2 plus y is 5 minus 8z equals 8. And now I can solve this. Half of negative 2 is negative 1. Negative 1 plus 5 is 4. Subtract 4 from each side. And then I divide both sides by negative 8. So I get z equals negative 1/2. So then I have what's called an ordered triple. I put x first, so negative 2, comma, 5, comma, negative 1/2. And this is how I would write the point of intersection for these 3 equations. Now that last example was the easiest case. This one, still not that hard, because if you look at the first 2 equations, you'll notice that you have 2 equations with just 2 variables. Well, you already know how to do this. So I'm going to use the elimination method, and I'm going to choose to multiply the second equation by a positive 2. I'm doing that so that I can make the y's be opposites so they can drop out. So I'm leaving the first equation alone. The second equation will now become 4x minus 2y equals negative 14. And then I'm going to combine those 2 equations. So I have 5x, the y's drop out, equals negative 10, and x equals negative 2. So now I know x. Since I know x, I can substitute into either one of the first 2 equations, and I'm going to use the first equation. So I get negative 2 plus 2y equals 4. If I add 2 to both sides, I get 2y equals 6. So y is 3. So now I know x and y. All I need is z. And we can go to the last equation and substitute. X is negative 2. Y is 3 plus z equals negative 4. So we get 1 plus z equals negative 4, or z equals negative 5. So my ordered triple is negative 2, comma 3, comma negative 5. So if I were to take a look at this system of equations, they're going to cross at the point -2, 3, -5. Now, the last example I'm going to do is going to take the most amount of work. You'll notice I have 3 equations, and all of them have 3 variables. So the key to start with is, for our first step, so I'll say step 1, choose 2 equations and eliminate a variable. Doesn't matter which variable you want to do, you want to eliminate. Sometimes there'll be an easy choice. I'm going to take the first 2 equations and I'm going to choose to eliminate the y. So I'm going to actually number these 1, 2, and 3, so then I can refer to them. So I'm going to use equations 1 and 2, and I'm going to eliminate y. So I have 3x plus y plus z equals 4, and 2x plus 2y plus 3z equals 3. So what I'll do is take this top equation and multiply by a -2. I'm going to put that underneath here, and I get -6x minus 2y minus 2z equals -8. The y's drop out. I'll have -4x plus z equals -5. Now, I still have 2 variables, so I'm going to now move on to my second step. Now, the second step, you might want to pause and write that down, is to choose 2 equations, a different combination of 2 equations, and eliminate the same variable. So whatever variable you eliminated first, that's what you're going to have to eliminate again. So I'm going to choose as my two equations this time, equations 1 and 3, and again I have to eliminate y. So the first equation was 3x plus y plus z equals 4. And the third equation was x plus 3y plus 2z equals 5. So I'm going to take the top equation. Remember, I have to eliminate y. So I'm going to multiply by -3. Now, had I chose to eliminate a different variable to start with in my first 2 equations, I'd be eliminating that same variable here. So if I write that beneath here, I have -9x minus 3y minus 3z equals -12. Combining those 2 equations, I get, whoops. All right, so if we combine those 2 equations, we get -8x, the y's drop out, minus z equals -7. Now I have a second equation with 2 variables. Now what I'm going to do is the same method that we've done numerous times before. I've got 2 equations with 2 variables, so I'm going to either eliminate the x or the z. So I guess this would be my third strategy. So I'm going to use these 2 equations and eliminate a variable. Well, if we can just get that written on there. So I'll have -4x plus z equals -5, and -8x minus z equals -7. Well, that's pretty convenient, because if I add these 2 equations together, the z's already drop out, don't even have to do anything. So we have -12x equals -12, and x equals 1. Now you might look at that and say, well, that was an awful lot of work to get that. Well, yeah, but now the hard part's done, because now I know x, And now it's just a matter of substituting values to find z next and then y. So I'm going to substitute. I have two equations to choose from, and I'm going to substitute x equal 1 into negative 4x plus z equals negative 5, which was this one right here. So we have negative 4 times 1, or just negative 4, plus z equals negative 5. So when I solve for z, I'm going to add 4 to both sides, and I get z equals negative 1. So now I know x, and I know z. So now I need to choose, go back to one of my original equations. So I'm going to use that third one, x plus 3z plus, or I'm sorry, x plus 3y plus 2z. And that was equals 5. So I'm going to substitute the values in. So I have 1 plus 3y plus 2 times negative 1 is negative 2. So we get 3y plus negative 1 equals 5. And if you add 1 to both sides, you get 3y equals 6. So y equals 2, and we're done. And my solution is 1, 2, negative 1. That's where the three planes would intersect. Here's a program I have called AutoGraph, and I've actually graphed those three planes already. You can see the three equations listed here, and those are the three equations we just solved algebraically. And this is kind of nifty because you can actually use the computer technology to find the intersection. So I'm choosing all three of those, and if I right-click, I can choose intersection. And actually, you can see right down here at the bottom, it gives me the results, and it says that the intersection is at the point 1, 2, negative 3. And I also think I can show this called the results box. Oh, and it showed me 3 times for some reason. But I can see that I have 1, 2, negative 3 is that point of intersection. And I can actually move this around, and you'll see that the point of intersection is right here, kind of in yellow. And that's actually where the three planes intersect at that point.